So today what we're going to work on is our procedure for solving an optimization problem. We've done this already in class, and we're going to just lay out some steps that you'll have for your notes and for the end of the year when you go back to study. So here are some steps that we're going to follow for each of our optimization problems. The first one is that we want to identify our variables, so our x and our y. After that, we need to translate our constraints into a system of inequalities. So all of these questions will give us a list of constraints. We need to translate them into algebra. After that, we're going to draw the polygon of constraints. So using that system of inequalities, we're going to make a graph all of our polygon of constraints, all of our inequalities to get the polygon of constraints. And then we're going to shade just that one area. We'll determine the coordinates of all of our vertices. We know that sometimes whenever we make our polygon of constraints, our vertices end up somewhere that's very easy to find from our graph. Other times it's a little bit harder to tell, and we need to solve using our system of equalities to find the vertex. After that, we'll find the rule of our optimization function. So our optimization function is described within our text of our question along with the constraints, and we've been practicing how do we distinguish between our constraints and our optimization function. Then we evaluate each of our vertices using our optimization function, so we find the value using that function for each vertex. And based on that, based on our evaluation of each vertex, we figure out which one is going to provide us with a maximum or a minimum value, depending on what the question is asking you. So right now, we're just going to work on one example it's actually from our workbook, and we're going to go through our solution set. So this is just one more practice example, very similar to what we've already done before. So it says, during the hockey playoffs, a shop owner decides to sell flags and caps, the Canadiens logo. He orders 6,000 items in total and expects to sell at least 3,000 flags and 1,000 caps. Moreover, he expects to sell at least twice as many flags as caps. If the net profit on a flag is $15 and that on a cap is $12, how many flags and caps must he sell in order to maximize his profit? So our first step is to identify our variables. So our variables here are the different types of items that he's selling. So what I'm going to say is this. Let's let X be our number of flags and Y be our number of caps. So now that we've identified our variables, we can actually translate our constraints into a system of inequalities. And it's going to look something like this. Our first inequality comes from this information here that he orders 6,000 items in total, and it looks like this. So X plus Y has to be less than or equal to 6,000 because that's the limit to the amount of items he's purchased to sell. Our second inequality comes from this, that he plans to sell, or he expects to sell at least 3,000 flags. He also expects to sell at least 1,000 caps, so this is our third inequality here. And our last inequality comes from this information here, that he expects to sell at least twice as many flags as caps, and that's going to look like this. Okay, so that's our set of constraints. We also have another two constraints down here. Those are always sort of in the background. We're not going to graph them. We're going to show them by only graphing in the first quadrant because negative values don't make sense for this question. Now we need to make our polygon of constraints. So I've got my system of inequalities here, and I cheated a little bit because I've already graphed this, but if you're using this as an example in your notes, this is what your polygon of constraints will look like. It's going to be this area here. I don't know if that's even going to be big enough for you guys to see. There we go. So those are our vertices on our polygon of constraints. Okay, so I've already graphed it at lightning speed, and I have to do that because you guys know what my graphs look like when I try to do them during class. I have to determine the coordinates of all of my vertices, which I've already done. For this graph, it worked out really, really well because all of my vertices fall on a nice even point, on a nice natural number. And I've been able to determine them, and the coordinates are down below here. So I have 3,000 and 1,000, 3,000 and 1,500, 4,000, 2,000, and then 5,000 and 1,000. And I've kind of already set this up badly because I'm giving away my optimization function, which is our next step. If we look at our question, it says the net profit on a flag is $15 and that on a cap is $12. How many flags and caps must he sell to maximize his profit? So we remember that during class I said that we should always be thinking about what our goal is here. Our goal, or his goal, is to maximize his profit. So we know that our optimization function will have something to do with money. And we know that the cost for the profit on a flag is 15 and the profit on a cap is 12. So whenever we write our optimization function, it looks like this. That's our optimization function. Okay, that's an expression that describes the amount of profit that he makes in total. And that's what we're going to try to maximize because we want him to maximize his profit. We jump back to our graph here. I've already got a little table set up so that I can check each of my vertices because we know those will be the locations of our maximum and minimum values. So I'm just going to take a second here and do a little bit of calculating to figure out where will my maximum and minimum value be. All right, so I've jumped ahead and I've done my calculations using my net profit optimization function, and I found these four values. So our maximum value is going to be right here. Okay, so the maximum amount of profit that he can make is $87,000. We need to go back and just revisit this question and make sure that we're answering what the question is asking us. So it's saying if the net profit on a flag is $15 and that on a cap is $12, how many flags and caps must he sell to maximize his profit? So they're actually not asking us how much his net profit will be when it's maximized. They're asking us for that coordinate, how many flags and how many caps. So how many does he have to sell? He needs to sell 5,000X and 1,000Y. So it says he must sell 5,000 flags and 1,000 caps in order to maximize his profit. And that's our final answer.